Okay, so we have another exponential function, y equals a e to the power of bt. Alright, and that's the number of bacteria present after t hours. Now, under certain conditions, the bacteria doubles every 6.5 hours. The question is, if there are 100 bacteria at the start, find the growth constant b. So, this is our function. We know there's 100 at the beginning. So what does that tell us? Yeah, that'll tell us A. You can fill it in just to be sure. So 100 when time is 0 at the very beginning. Okay. E to the power of 0 is 1, so A is 100. Everyone okay with that? So this now is my equation. The bacteria doubles in population every 6.5 hours. So every 6.5 hours it doubles. So after 6.5 hours, what will the amount of bacteria be? 200, exactly. You're doubling what it was. If we're talking about doubling time, when I divide that, it's always going to be 2 equals. Okay, 200 over 100.
I don't really understand that thing. Why did you put the 200 and the 100 in the same?
In here?
Yeah.
Well, I know that A now is 100.
Yeah.
So that's my initial value. So that's 100. There's my function now. Okay? After 6.5 hours, the amount of bacteria has doubled. If it was 100, what is it now? 200. So 200 is, and this is just my equation, but instead of time, it's after 6.5 hours.
So then you just have to find B.
So now I'm trying to find B, exactly. Find the growth constant B. All I'm doing is filling in what they gave me. Now, this is my base power value. So log to the base E of 2 is 6.5B. So ln of 2 is 0.693147 is 6.5B. And how do I get what B is? Divide by 6.5.
He's using ln shorter than that.
Is that okay? There's your growth constant. Okay, another example. Can I get rid of this? So, logs can be used to deal with questions using the Richter scale, okay, or the decibel scale, so earthquakes or sound, okay. So we'll do an earthquake one here. Is this example 5?
Yeah.
this is approximately. Okay, it's an equals and they have a little squiggle over it. Okay, so we have a formula for the intensity, A equals 10 to the power of m, and we have a formula for the energy. Okay, so we have two different formulas. The question is asking us to compare the intensity of an earthquake of magnitude 6.1 with an earthquake of magnitude 4.7. So we're actually just going to get both intensities and compare them. Okay, so this is our intensity formula. A is 10 to the power of m, where m is the magnitude. Okay, so our first earthquake is magnitude what? 6.1. So it's just going to be A is, and you could call this 1 if you wanted. A is 10 to the power of 6.1. And the next one, A is 10 to the power of...
Excuse me, please. Could the following come to reception at the bell, please? Amy Sheehan, Patrick 1, Kesa O'Brien, Hannah Minahan, and Joan Moore. Thank you.
Okay, and if we're trying to compare them, we're trying to see which would be stronger and how many times stronger. So we're going to divide. Okay, so 10 to the power of 6.1 over 10 to the power of 4.7. And it comes out as 25. Okay, so it's 25 times as intense as the other one. Is that all right?
Which one is 25?
So 1 is 25 times 2. You could call that A1 if you wanted. A1 is 25 times A2. The one on top is bigger. Okay. And then they want us to compare the energy. So we need to just get our energy formula. So our energy, 1.5 m plus 4.8. So it's the same thing again. We can get our E1, which is going to be 10 to the power of 1.5 by the magnitude of the first, which is 6.1, plus 4.8. And just throw that into your calculator. We're going to do E2, same thing. Put in your magnitude, which in this case is 4.7. So you're just filling into a formula here. Same thing, we're going to divide. So that tells me E1 is approximately 126 times E2.